Both are directly connected. Let's say this is R1. This one is, let's say, R2, router 2. This is nothing but, let's say, F0/0, and this is, let's say, also F0/0. Done. Here router 1 have one LAN network. Here we have one LAN network, and router 2 have also one, let's say, LAN. LAN means local area network. Both router have one private network connected to router, like this. Okay. Here let's say my network is 192.168.0.0. Let me reduce the size. Here hope size, the text is visible to you.
Yes.
Let's say 10.0/24. Is it visible, guys?
Yes.
Yes.
Copy it, and here
So
I
what's
have.
different between dynamic routing and static routing?
Yeah, yeah, soon we are going to understand this. Don't worry. This is the LAN over here, router 2, and this is, let's say, F0/1, and this is also F0/1. Here I have configured IP address, let's say 12.1.1.1, and here IP address is, let's say, 12.1.1.2. Guys, by default, as you know, both router maintain routing table. Yes or no? Router 1 will have one routing table, and router 2 will have one routing table. Yes or no?
Yes. In both have the same network?
No, in the both routing table there will be directly connected network. Here there will be 12.1.1.0/24, and this network is connected on fast Ethernet 0/0, and there will be one more network 192.168.10.0/24, and this network is connected on F0/1. This will be the entry inside the routing table of router 1. Yes. And if I will talk about the routing table of router 2, so here there will be also two entry 1.1.0/24 connected on F0/0, and there will be one more entry 192.168.20.0/24 is directly connected on
Okay.
F0/1. So
That's
there
why
will be,
you route both are the same in the you see the both IP network.
both are
This,
directly connected.
no, no, the IP address you said like 192.168.10.0
No, no,
in
here
for the
it is
router.
not 10.0, sorry, it is 20.0. Let me correct it. This is not 10.0, this is 20.0. Let me write again. 192.168.20.0/24. Okay,
Yes.
done, guys. So see, router 1 don't have information about 192.168.20.0 network, right? And router 2 don't have information about 192.168.10.0/24. Yes or no? Means by default, as you know, router know only directly connected network. So here we are able to see router 1 is connected with two directly connected network, 12 and 192.168.10.0. So there is information about those two network only. And on router number 2, we have two directly connected network, 12 and 192.168.20.0. So router 2 have information about these two network. But what about the indirectly connected network? Like 192.168.20.0/24 is indirectly connected from router number 1. Yes or no?
Yes.
And 192.168.10.0 is indirectly connected for R2. So in static routing, manually you are defining the indirectly connected network on router. Yes or no?
Yes.
On router number 1, you will define which network? Yes,
Two
on
networks. Uh,
192.168.20.0.
20.0. Only one network is indirectly connected from router number 1. So that network we will define on router number 1. And router number 2, you will define which network?
10.0.
10.0.
10.0. Okay, so in static routing, manually network engineer are adding routes in the routing table of router. So it is good, but it is very complicated to implement a static routing in large network. Let's say I have a network like this: router 1, router 2, router 3, router 4, router 5, and these all routers are directly connected like this, and each router have 1000 prefixes. Let's say each router have 1000 prefixes, so it is possible to configure 1000 root on all routers? No, 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 it will be very complicated task. Yes or no?
Yes.
Yes.
So static routing is suitable only for a small network. When our network is very small, network size should be small, then we can configure static routing. In large network, we cannot configure static routing. So in large network, what is the solution? In large network, solution is dynamic routing. Guys, in dynamic routing, we will simply run one process on router. We will run one process on router and same process on router number 2. According to that process, router itself will exchange the routing table. Let's say router 1 will send their routing table to router 2. What I am saying, if router 2 will send the routing table of router 1 to router 2, let's say this routing table to router 2. Now router 2 will learn which network? 192.168.10.0. Yes or no? Because router
Yes.
1 has here their routing table to router 2. In the routing table of router 1, which router 2 have received, there is one network which is indirectly connected. Yes or no?
Yes.
So it will learn that network in their routing table, that 192.168.10.0/24, and I am learning this network on F0/0 interface like this. It will make one more entry in their routing table. Done. In the same way, router 2 will also share their routing table to router 1. So router 1 will also learn which network? 192.168.20.0/24, and this network is reachable via F0/0 because it will receive update message on F0/0. Getting my point? So in dynamic routing, simply we will run a process on router. According to that process, router itself will exchange their routing information with neighbor router. Getting my point? Now let's say I have a topology like this: R1, R2, and let's say R3. We have three router, very simple: R1, R2, and R3, like this. R1, R2, R3. Now here we are running network 12.1.1.0/24 between router 1 and router 2. Between router 2 and router 3 we are running network 23.1.1.0/24. Let's say IP address of this interface is 12.1. Here IP address is 12.2. Guys, these things should be clear to you. Yes or no? Is it clear to
Yes.
everyone?
Yes.
Yes, because we had discussed lots of time. Here IP address is, let's say, 23.2, and here IP address is 23.3. Done. Now router 1 have one network 192.168.10.0. Here router 3 also have one network 192.168.20.0/24. Here also /24. So in dynamic routing, what will happen? Router 1 will share this network 192.168.10.0 network with their neighbor, means to router 2. And router 2 will share this network information to router 3. And this is how router 3 will learn 192.168.10.0. In the same way, router 3 will share this network information to their neighbor to router 2, and router 3 will share this network information to their neighbor to router 1. And router 1 will learn 192.168.20.0/24. Getting my point? Getting my
Yes.
point, guys? This is how router 1 and router 3 will learn the network indirectly connected network, or and router 2 will also learn 192.168.10.0 also and 192.168.20.0 also. 10.1 from router number 1 and 10.0 from router number 1 and 20.0 from router number 3. Router 2 will learn both network. Let's say here I have one more router. Router 4. Now this time, tell me router 1 will learn 192.168.20.0, which is connected on router number 3. Will learn means my question is very simple, guys. Let me elaborate my question. Question is this network. I'm talking about this network. Router 1 will learn this network from how many side?
From two sides.
From two side, definitely. Router 4 will also advertise. Router 2 will also share to router number 1 and router 4 will also share to router number 1. Yes or no?
Yes.
Yes.
Now router 1 need to find that which one is best path. Router will find which path is best, because now router have two choice. Either it can reach in this network via router number 2, or it can reach in 192.168.20.0 via router number 4. So whenever router will receive same network information from multiple path, from multiple neighbor, router calculate the best path. And in dynamic routing, the most important thing is best path selection, that how router select best path. So for the best path selection, first thing that router is going to check is longest prefix match. First thing is longest prefix match. Let me write over here. Longest prefix, we can say length. Means longest prefix length means, let's say I have a two network 192.168.10.0/24 and 192.168.10.0/25. Getting my point? I have two network now. So which network is best? Which network is more reliable? This one. Because here we have longest prefix match. Prefix length over here is 25. Prefix length over here is 24. This is the first way. Router check. That router check. First thing that router check for the best path selection is longest prefix length. Done? But in my scenario, see, when router 1 or sorry, not router 1, router 2 will advertise 192.168.20.0/24, and router 4 will also advertise 192.168.20.0/24. Yes or no? Means in my scenario, longest prefix length is same from both sides. So on the basis of longest prefix length, now router 1 cannot decide which one is best. Yes or no?
Yes.
Then router is going to check the AD value. Second thing is AD value. AD stands for administrative distance. Administrative distance. Or sometime interviewer is also asking what is AD value. So guys, always keep in mind AD value is nothing but the trustworthy of a route. It is an trustworthy of a route. Lower value is always best. Lower value is always best. Getting my point? And each routing protocol, we have multiple routing protocol, and each routing protocol have predefined AD value. Like if I will talk about RIP, so RIP have a AD value, EIGRP have a AD value. All routing protocol have one separate AD value. Getting my point?
Yes.
So let's say here what I am saying, here I am running different routing protocol and here I am running different routing protocol. That can be possible. Then AD value will be different. But if we are running same routing protocol in this domain, then AD value will be also same. Let's say here AD value is X and here also AD value is X. Now AD value is also matched on router number 1, right? So router cannot decide which path is best path on the basis of AD value. Then third thing that router is going to check is metric. And each routing protocols have their own algorithm to calculate metric. And metric is also lower value is best. Lower is best. Done. So routers are going to check these three things, guys. These three things. On the basis of these three things, router will decide which path is best. If all three things is equal tie, then router will perform load balancing. Let's say router 1 is receiving this network 192.168.20.0/24 with prefix length 24. Let's say AD value is 1110 and metric is, let's say metric is 200 from both side, from router number 1 also, from not router 1, from router number 2 also, and it is receiving same network information from router number 3 also. Sorry, 192.168.20.20.0/24 from R2 with AD value what? Let's say AD value is 110 and metric is via router number 4. So see, router 1 is receiving this network from two sides, from router number 2 and from router number 4. Yes or no? From both sides,
Yes.
prefix length is same.
24.
AD value is same and metric is same. So if these three things will be same, then router will perform load balancing. It will install both path in their routing table. If I will talk about the routing table. So in routing table there will be two network 192.168.20.0/24 is reachable via router 2 also and router 4 also. Getting my point?
Should error to not be.
router 1 will receive this network from both router, via both router. It can forward traffic to router 3 also, and it can forward traffic to router 4 also. This is the funda of dynamic routing. Is it clear?
Yes. I think it's not router 3, it should be router 2.
Yes, it is router 2. It is router 2. Done.
Yes.
Now we have multiple types of dynamic routing protocol. First type of dynamic routing protocol is distance vector routing protocol. First one is distance vector routing protocol. First of all, you should have knowledge about why we are using dynamic routing. So it should be clear to you that it is very complicated to implement a static routing in large network. That's why we come up with dynamic routing. Yes or no?
Yes.
In
Yes.
dynamic routing, we have three parameters for best path selection, that how router will decide which path is best whenever router will receive a same network from multiple sites. First is prefix length, then AD value, and then metric. After that, types of dynamic routing. So first type of dynamic routing is distance vector routing protocol. Then second type of dynamic routing protocol is link state routing protocol. Third type of routing protocol is advanced distance vector routing protocol. And fourth type of dynamic routing protocol is path vector routing protocol. So we have these four types of dynamic routing protocol. Guys, distance vector routing protocol, we have two types of protocol in distance vector routing protocol. RIP version 1 and RIP version 2. If I will talk about the link state routing protocol, so we have only one routing protocol for now in link state routing protocol, that is OSPF. Or we have one more types of link state routing protocol, that is ISIS, but that is not a part of my syllabus. This protocol is not part of my syllabus, so let me remove it from here. After that is advanced distance vector routing protocol. Advanced distance vector routing protocol is nothing but EIGRP. And then we have path vector routing protocol, that is BGP. So we need to understand these routing protocol one by one, like RIP version 1, RIP version 2, OSPF, EIGRP, and BGP. These are the very important routing protocol in case of dynamic routing. Okay. Okay, guys. So till here, everything is okay.
Yes.
Yes.
Okay. Now what I am going to do, I am going to introduce you to one new file. Dynamic routing, this one. So first of all, see dynamic routing. In dynamic routing, we will run a process on router, and router will share their routing information on the basis of that process. Done. Router need what information to build a routing table? Router need remote network, means destination network, remote subnet mask, and next hop IP address to build the routing table. Yes or no? In a static routing also, whenever you are configuring the static routing, you are configuring what? Destination network means remote network, remote subnet mask, and next hop IP address. And in dynamic routing also, router need these three information to build the routing table, right? In a static routing, network engineer will provide these information to router, but in case of dynamic routing, router itself give information to their neighbor router. Done. Like if I have a topology like this, so here router 1 and router 2 will exchange the routing information with each other. On the basis of that process we will run on the router. After that, drawback of static routing. So complex to implement in large network, and we don't have backup path as well in static routing. But if you want to configure the backup path, you can configure, but by default we don't have redundancy for default for static routing. Done. Then types of dynamic routing, as I told you, first type of dynamic routing is distance vector routing protocol, then link state routing protocol, then advanced distance vector routing protocol, and then path vector routing protocol. Now we need to understand the properties of each dynamic routing protocol. Let me start the properties of first routing protocol, that is distance vector routing protocol. Here you can see distance in the networking means number of hops. Number of hop means your layer 3 device, means router. Done. That means every distance vector routing protocol will calculate their best path on the basis of hop count. Yes. On the basis of hop count, it will calculate the best path. That means metric in distance vector routing protocol is number of hop. As I told you that each routing protocol have their own algorithm to calculate metric. So this is algorithm of calculating metric of distance vector routing protocol. Here metric is number of hop. Let me design one topology over here. I have a router 1 here, router 2, router 3, and let's say router 4. We have 4 router, all router are directly connected. R1, R2, R3 and R4. Done. Router 1 have one network 192.168.10.0/24, let's say. So router 1, and on these router we are running routing protocol, distance vector routing protocol, that is, let's say RIP. Here also I am running RIP on router number 1. On router number 2 also I am running RIP. On router number 3 also I am running RIP routing protocol, and on router number 4 also I am running RIP. So router 1 will advertise 192.168.10.0 network to router number 2. It will share this network to their neighbor 0/24. Now what will be the metric on router number 2? Metric will be, we are running distance vector routing protocol, so metric is hop count, means how many hop destination network is away from router number 1. One hop away, there is only one hop, that is router 1, between router 1, router 2 and destination network. Yes or no?
Yes.
So metric on router number 2 will be 1. Metric on router 2 will be 1. After that, router 2 will also advertise this network to their neighbor, to router number 3. Same network 192.168.10.0/24. What will be the metric over here, guys, on R3?
2.
Metric will be 2. That means 2 hop, destination network is 2 hop away from me. After that, router 3 will also advertise this network to router number 4. same network 192.168.10.0/24. And what will be the metric on router number 4?
C.
Metric will be 3 over here. Yes or no?
Yes.
Now let's say router 1 is also receiving same network information from their other neighbor, from someone else. Someone else is also giving same network information to router number 1. Network information is 192.168.10.0/24. But here metric is let's say metric is equal to 5. So router 4 will accept which route? Via router number 3 or via router number someone else? So as you know, list metric is always best.
Yes.
That means the router 3 is advertising the best route to router number 4. It will not accept this update message. It will discard it. Yes or no?
Yes.
Okay. Now, this is the concept of metric. So metric in distance vector routing protocol is simply number of hop. After that, we have some concept of loop avoidance mechanism in distance vector routing protocol. Let me discuss that also. But vector means, guys, direction. Direction means next hop IP address. Distance vector routing protocol always sends periodic update to their neighbor after a periodic interval of time. What is the meaning of it? The meaning of it is distance vector routing protocol send a periodic update. Periodic update means it will send one update after a specific interval of time. See, router 1 has here one update message to router 2. In the update message, it has here 192.168. Update message. In the update message, it has here 192.168.10.0/24 network to router 2. Now router 2 have knowledge that this network is reachable via router number 1. Yes?
Yes.
Now again, do you think router need to send same network information to router 2? Do you think again router 1 need to send same network information to router 2?
No.
No, but it will send. It will send a periodic update. It always send periodic update. After a specific interval of time, we will understand that timer, but it will send periodic update. Periodic means sending update message continuously after a specific interval of time. Okay? Wait. This is problem of distance vector routing protocol, and this is also one of the reason why we are not using this routing protocol nowadays, because it is sending periodic update. Done.
Yes.
After that, let me make you understand the second problem of distance vector routing protocol. Let's say I have a topology like this. R1. Here I have router 1. Router 2 and router number 3. R1, R2 and R3. Here bandwidth is, let's say, here we have 1 Mbps link. Here we have 100 Mbps link. Here also we have 100 Mbps link. 100 Mbps link. Now router 1 have one network, that is 192.168.10.0/24. Getting my point? Router 1 have one network 192.168.10.0/24. So it will advertise to their neighbor. Router 1 will share this network information to router 2 and to router 3. Yes or no? Yes, brother?
Yes.
Yes. Yes.
Here there will be network information of 192.168.10.0/24. Here also network will be 192.168.10.0/24. And router 3 will also advertise this network information to router 2. Same network information 192.168.10.0/24. Now tell me, router 2 is receiving same network information from two side or not?
Yes.
Here also it is receiving 192.168.10.0/24 via which router? R1, and it is receiving same network information via
R3.
which router? R3. 192.168.10.0/24 via R3. Now router 2 need to find which one is best path. So how it will find which one is best path? First of all, it will compare the prefix length. So prefix length is same. Then it will check AD value. So AD value will be also same because both sides is receiving from the same routing protocol. So same routing protocol will have same AD value. Then it will check what? Metric value. So what will be the metric over here? What will
100
be
Mbps.
metric?
It
Yes,
should 1.
it should be 1. And metric over here?
100.
Not 100. How many hop away destination network is via this side? 2 hop away.
3. Yeah, 2 hope.
So,
Yeah.
so metric over here will be 2. So it will install which path in their routing table? Via router number 1 or via router number 3?
Router number 1.
So it will discard this entry? Yes or no?
Yes.
It will remove this entry. But means according to distance vector routing protocol between router 1 and router 2, best path is this path. Best path is this path, yes or no?
Yes.
Yes.
But according to you, can you tell me which path is best path?
According
Because
to
here
what?
you can see we have only 1 Mbps link. According to you, which
Mhm.
path is best path between router 1 and router 2?
Yeah, it's
Here we
router.
have 100 Mbps link. Here we have 100 Mbps link. Definitely lower path is best path. This path is best path, yes or no? Because we have good bandwidth in lower path, but we have least bandwidth on upper path. So lower path is the best path. This path is the best path between router 1 and router 2, yes or no? Is it clear?
Yes.
But according to RIP routing protocol or distance vector routing protocol, this path is the best path. So distance vector routing protocol does not consider link properties to calculate metric. This is also one disadvantage of distance vector routing protocol. Yes or no? It should at least check the bandwidth of link. It should calculate metric on the basis of bandwidth. Yes or no? But it is calculating metric on the basis of hop count only. This is also one of the reason why we are not using distance vector routing protocol nowadays. Okay, is it clear?
Yes.
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 Okay, so according to here, if we will configure RIP routing protocol, so router 2 will install best path via router number 1, directly this path, right? But if you will configure any other routing protocol like link state or advanced distance vector routing protocol or path vector routing protocol, definitely router 2 will install this network via router number 3, because those routing protocol calculate metric on the basis of link property. But distance vector routing protocol does not have capability to calculate metric on the basis of links. This is also one disadvantage. Anyone can ask you what is the disadvantage of distance vector routing protocol, why we come up with link state vector routing protocol. Okay. After that, how we can prevent loop in advanced distance vector routing protocol. Let's say I have same topology, router 1, router 2 and router 3. Let me delete this thing. Like this. Again, router 1 have one network 192.168.10.0/24. So brother, router 1 will advertise this network information to router 2, yes or no? And it will advertise to router 3 also. Router 3 will advertise to router 2, and router 3 is receiving one update message from router number 1, and this update message should be advertised by router 2 also from this interface to router 3, yes or no? Means what I am saying, that when router 2 will receive one update message from router number 1, it have received this update message from router number 1, so it will advertise same network information to router 3, and router 3 will also advertise same network information to router 1. Now this is what? Loop. This is loop. Yes or no? Because
Yes.
router 1 is advertising 192.168.10.0/24, and now same router is learning same network information from their neighbor. This is loop. Yes or no?
I don't understand about loop. Like, what
See,
exactly?
router 1 have this network information done. It will
Yes.
advertise to, let's say, router 2, then router 2 will advertise to router 3, then router 3 will advertise to router 1. Yes or no?
Yes.
So when, let's say, you are saying that I know CCNA, if
Mm-hmm.
anyone want to learn CCNA, you can send him to me. Done. This is your statement,
Yes.
right? Okay, you send your information to me. I send my your information to Abdul. Okay, let's suppose, and now Abdul is giving you same information. I know CCNA. If anyone want to know learn CCNA, you can send him to me. Now this is what loop. You are broadcasting this information, and now you are getting same information from Abdul. Yes or no?
Yes.
So this is loop.
Okay. Got it.
So router 1 is advertising this network information to router 2, and it is learning same network information from router number 3. That means this is nothing but the loop. And see, now router 1 is advertising this network from this interface also to R3. So to not form this type of loop, we have a concept of split horizon in EIGRP, in distance vector routing protocol. Here we have concept of split horizon. To prevent loop, we have concept of split horizon. Like in this diagram, you can see router 1 is advertising one network, A network, yes or no?
Yes.
And router 2 is also advertising same A network information to router number 1, yes or no?
Yes.
This is what? Loop. So rule is, a split horizon rule is, whenever you are receiving a network information on an interface, you will not send same network information from that interface. Whenever you are receiving a network information on interface, you will not send that network information from the same interface. Means if you are learning a network on this interface, you will never send a network from this network. from this interface. Getting my point? This is rule of split horizon. Getting my point?
Yes.
So this is also a concept of distance vector routing protocol. Split horizon is used to prevent loop. Okay. After that, we have properties of link state vector routing protocol. So guys, link state routing protocol is very important routing protocol that we are using nowadays. So please try to understand this very carefully. First, think about link state vector routing link state routing protocol is it maintains three types of table. It maintains three types of table: neighbor table, database table, and routing table. So when we will configure link state routing protocol, let's say on these three routers, these routers are not going to exchange routing information directly. First of all, router will become neighbor. Router will maintain one neighbor table. In the neighbor table, they will keep information of neighbor router. First of all, router will build neighbor table. After building neighbor table, it will build one database. And after building the database, it will build the topology table. You will understand in OSPF. OSPF is a link state vector routing protocol, that how this protocol works. But just I am giving you an overview of this routing protocol. So just try to understand the properties. Okay.
Yes.
You guys have basic knowledge about OSPF or about EIGRP or not?
No.
You guys don't know anything about this protocol, right?
No.
So that's why we're taking you from the very beginning. No one will teach you the properties. Directly, trainer will start OSPF or EIGRP, right?
Yes.
I am making you understand the properties first so that you can understand OSPF or all link state routing protocol very carefully, very clearly. Okay.
Thank you.
So in link state vector routing protocol, always keep in mind link state vector routing protocol maintain three types of table. I will share this file with you. Please read once.
Okay.
In case of distance vector routing protocol, information was directly exchanged between router. But in case of link state routing protocol, router will not directly share the information. First, all routers will check some parameter, then router will become neighbor. After becoming neighbor, router will exchange database. After exchanging database, router will build their own routing table. Getting my point? In link state routing protocol, we have some periodic update as well, and we have some trigger update as well. Trigger update means as distance vector protocol share periodic update only. Yes or no? It sent periodic update always. But link state routing protocol can send trigger update, means whenever change will occur, then only it will send the update message. Otherwise, it will send only one message, one update message. And there is one periodic message, that is hello message. So we will discuss about that message also. So for now, what you can understand, that link state routing protocol send periodic message as well and trigger message as well. Okay. Trigger update means when there is a change in topology, router will send a trigger update. Here metric is depend on link properties. Very good. Yes or no? In distance vector routing protocol, metric is hop count. Node depends on the link properties. But here you can see metric is dependent on link properties. So it will have one formula to calculate metric. Okay.
Yes.
Yes.
Here we don't have routing by rumors, but in case of distance vector routing protocol, let's say here we are running distance vector routing protocol. So it have advertise this network information to router 2 and to router 3? Yes or no?
Yes.
Router 1 will advertise to router 2 also and to router 3 also. Yes or no?
Yes.
And router 3 will advertise to router 2. Right? Let's say router 2 have installed, receive, learn this network via router number 3. So router 2 don't have any information about router 1, that who is actual originator of this network. All routers are depend to their neighbor only. Let's say here we have one more router R4. So router 2 will advertise this network information to R4 also. To router 4. Now router 4 will learn this network via router 2. Yes or no?
Yes.
So router 4 know only about the router 2, that this network is available on router number 2. Router 4 don't know that who is actual originator of this network. Actual originator is R1. Yes or no? Not R2.
Yes.
So in distance vector routing protocol, all routers are depend to their neighbor router. That router 4 will think that this network is connected to router 2. So this is what routing by rumors. But in case of link state routing protocol, all routers will have the information of entire topology. Router 4 will have information about this network, that this network, router 2 is not actual advertiser of this network. R1 is actual advertiser of this network. By checking their database, router 4 can check their database and can design the entire topology. But distance vector routing protocol cannot design the topology by checking their own database, because all routers are depends on their neighbor. Like you have give information to me that you know CCNA, I have give the information to Abdul. Abdul will think that Praful knows CCNA. So whenever I need to learn CCNA or someone need to learn CCNA, I will send him to Praful. But I am not the actual trainer. You are the actual trainer, right?
Yes.
So this is the problem of distance vector routing protocol. In distance vector routing protocol, all routers are depend to their neighbor. But in case of link state routing protocol, all routers will have information of full topology. Done. In distance vector routing protocol, we have limit of hope as well. We can connect only 15 routers in a series, but here we can connect unlimited router. We don't have any limit. Okay,
Yes.
done. After that, we have some types of updates, so we will understand this later. And then we have advanced distance vector routing protocol. So we have, advanced distance vector routing protocol is combination of distance vector and link state routing protocol. It has combination. Like as I told you, there are 4 types of dynamic routing protocol: distance vector, link state, advanced distance, and path vector. We are not going to discuss path vector now. We are going to discuss these 3 dynamic routing protocol first. So we had discussed distance vector routing protocol. We had discussed link state. Now advanced distance vector is combination of both. It has some properties of distance vector and some properties of link state routing protocol. Getting my point?
Yes.
So here you can see advanced distance vector routing protocol is combination. Advanced distance vector routing protocol has some properties of distance vector routing protocol as well as some properties of link state routing protocol. Advanced distance vector routing protocol also maintain 3 types of table. This is behavior of link state. Yes or no?
Yes.
This is behavior of link state. It consider hop count. This is behavior of distance vector routing protocol. It calculate metric on the basis of link properties. This is property of link state routing protocol. So you can see it is using properties of both. Okay. Now guys, we have first type of routing protocol, that is RIP. First type of dynamic routing protocol, that is RIP. And RIP is an distance vector routing protocol. First thing is this. Here you can see RIP. RIP is a distance vector routing protocol. OSPF is a link state routing protocol. So when I will start OSPF, I will use these properties of link state routing protocol. We'll discuss. So now we are going to start RIP. So I'll try to keep in mind the properties of distance vector routing protocol. So you tell me, you want to start your first dynamic routing protocol from today or from tomorrow?
It should be from tomorrow.
From tomorrow, right? So that we can finish it as well.
Yeah, because if we need to like stuff on.
And you need to learn the properties, right?
Yeah.
So please read this file, read your book, and try to understand the properties of each routing protocol, dynamic routing protocol. Guys, dynamic routing is very important in CCNA. For next 20 to 30 days, we are going to understand routing protocol only. Okay.
Okay.
So we have lots of command, we have lots of configuration, we have lots of troubleshooting in all dynamic routing protocol. Nowadays we are definitely not using RIP routing protocol, but to understand other routing protocol, you have to understand RIP. And in a small network, we are still using as well. Okay. So as I told you that each routing protocol have their own AD value. So here you can see the AD value of RIP is what? 120. AD value of RIP is 120. Okay.
Okay.
I am sending this file to you in WhatsApp group.
PM, I have a question.
Yes.
Today I had a static routing, but I have one question. Can I share my screen with you?
Question from a static routing?
Yes.
Yeah. Go ahead.
Did I share my screen?
Yeah, I'm able to see your screen. Good.
Right here at I just route the router 3. Right here, you see, sir, IP routing.
Yes, I'm able to see.
192.168.
IP route 192.168.10.0. On router number 1, why you are defining IP route 192? This network is directly connected to router number 1. Router have already information about this network, brother.
Okay. Then for the router 3, what I should do?
Here router 1 don't know about 192.168.50.0 network.
But I already did it for in router 1. This.
You need to define only indirectly. Okay, you are on router number 3. Sorry. I was thinking that you are on router 1. Okay, on router number 3, you have defined this network. It's fine. Subnet mask is fine. 192.40.1. 40.1. Okay, it's fine. Yes, it is correct.
Okay, if it's correct,
Yes.
what I have to do next?
Next, you need to check the routing table first of all. So IP route. Here you can see there is one entry 192.168.10.0. Perfect. Now you need to configure a static routing on other routers, like on router 2. Let me show me the routing table of router 2. So IP route. Here you have configured a static routing 192.168.10.0 via 192.168.20.1. Perfect. and 192.168.50.0. Next hop is 40.2. Perfect. Let me show me the routing table of router 1. So IP route. Static routing 192.50.0/24. Next hop is 20.2. Perfect. You have configured static routing perfectly. So now your LAN user can communicate with each other.
Okay. Let me come to the PC1.
Yeah.
I'm gonna ping
To PC2.
PC. Okay, PC2. There is no PC2. PC2. Yes. But it's not working.
So have you defined the default gateway IP address on PC?
Yes.
Can you run show command here? Show. Yes, that's it. Hit enter. Here IP address is this one. Get default gateway.
There's
No. Here you have configured the wrong. Configuration. Say IP.
Right here.
Yes, right here IP. After that IP address of the machine 192.168.10.10
14.
/24
I think this is not 10.10. 10. It's 10.10.
10.10
Yes. Oh,
/24.
24.
After that a space and then gateway IP address 192.168.10.1.
okay.
I told Ilham I have to do it like this. He said like no, don't do it like this.
Now you need to provide the gateway IP address 10.1.
Yes.
Yes,
No,
hit
that's
enter.
correct. Yes.
And in the same way you need to configure PC2 also.
Yeah, got it.
PC3. Yes, now you can check the communication between end devices. Ping. You can see you are getting the reply. Soon you will get reply.
Yes, got it.
Done.
Yeah, thank you so much, sir.
It's working. So you guys are learning these things for first time. So that's why you need to practice a lot.
Yeah. So I have a question in same topology.
Yes.
Well, could you please minimize your yeah, this one. That's it. If you have another network, like if another pieces connect to R2, right?
Okay.
Like that, then like, and we do routing table from router one. We supposed to like route 192.168.50.0,
The
or we should do the middle one,
middle
192.168.
one, middle one, middle one. Then you need to define middle network on router number 1 and router number 3.
Okay, if you route from PC1 to PC3, right, and PC2 as
Okay.
well. First, we need to like route from network one to network two, then from network one to network three, right?
Right.
We do like step by step, like how we did with like.
Yes, step by step. Here, on router number 1, I just need to add 192.168.30.0. And on router number 3 also, I need to add 192.168.30.0.
Good. And also we need to like add from router number two, both networks, right? We already did that one. Yeah, got it. Thank you for that. Yeah.
Yes. Okay, guys. Then that's all for today. We will meet tomorrow.